Hi everyone, this is Babaiah, Assistant Professor of EC Department from MLR IT, Hyderabad. Previous we learned the what are the block diagram reduction rules. We have a lot of rules are there. All that we learn from the previous session. But today we are going to derive the transfer function or calculate the transfer function by using the block diagram reduction rules. For that, I'm going to consider the one problem here. Just here, reduce the block diagram shown in the figure. That figure I'm going to draw here and find the transfer function, that is C by R. Now I'm going to consider the input signal is R is given to the summing point and gain G1, G2, gain G1 and G2, and summing point is here, second summing point here and here. In between these two I am going to consider the one feedback, that is H, and from here G3, that will be given to here. This is the C. This is the given block diagram. From this, now we are going to use the block diagram reduction rules and reduce the blocks into the single block, that is called as the transfer function. The transfer function is the ratio of output to the input, C by R. So here now I am going to use the one rule here. See, observe in this block diagram, this is the take-up point, here take-up point between the summing point and block, but here we need to moving this take-up point to the after the block G1. So that is the one of the rules we have a block diagram reduction. In that we have a one rule is there, that is the take-up point, this take-up point is moving after the block G1, after the block G1. What we are going to write in that feedback, just I am going to say here, first step, in step 1 we are going to do this one, moving the take-off point, this is the take-off point or branch point, both are the same. Take-off point or branch point after the block, here this take-off point moving after the block G1. After that we are going to redraw the given block diagram by using this rule. Just see, observe here, the given input signal is here, input is R, and here summing point same as, and here G1 and G2, here summing point, this is the C output. Just here observe, take-up point is moving after the block G1. So here shifted to here after the block. The remaining block is same as, this is the feedback H, feedback gain, and here in this, by using this rule we are going to draw the write the in feedback block G1 after the block G1, right? We are moving the take-up point after the block G1, so we need to write the 1 by G1 in block value, directly 1 divided by G1. After that, this is already we have a G3 is available, and after finally this will be enter into the summing point. This is finally we get by using this step, or else by using this moving the take-up point after the block. Next, here just observe these 1 by G1 and G3, these two are in the cascaded, right, or else in series. So we have a one rule is there, by when the two blocks are in cascade form, we are going to just combine the two, means multiply the two block gains. Now the second step, in the second step I am going to use combining the cascaded blocks or series blocks. Just here, these two are just combined. Now I am going to redraw that one. Is after applying the rule, second rule, here are the summing point G1, gain G1 and gain G2, and summing point, this will be, these two are in cascaded, means here just observe here, these two are in cascaded form. 1 by G1 into G3 means G3 divided by G1, G3 divided by G1, G3 divided by G1, this is. And also we have one feedback loop is available, one feedback loop. This is the feedback element, the feedback gain is H, negative feedback, end with the negative sign. Okay, this is finally we got by when we are applying the second rule. Just here observe, we have one more, this is the one negative feedback loop, and just observe the signal is moving from here to enter into this summing point, and here also the signal is same passing to summing point, means these two are in the same direction, these two are in added into the single summing point. So these two are in parallel form, and these two are in the negative feedback loop. Here this is the feedback, the signal is passing to G1 and after it will be moving to the input side through the feedback element H. So now we are going to use the two rules here. One rule is the eliminate the negative feedback loop by using this loop, and this is the combining the two parallel blocks. When the two parallel blocks are available in a given block diagram, now we are going to just adding the two blocks, right? Here just these two are the, this signal is enter into the again input side, means so these two are in the form of loop. So what is which loop here? The signal is end with the negative, so this is the negative feedback loop. Now we are going to use the one more rule, that is in step 3, eliminate the negative feedback loop, eliminate the negative feedback loop G1 and H, eliminate the negative feedback loop, we get the R, and these two are negative feedback, means in single block just I am going to write the G1 divided by 1 here, end with the negative, so positive, and G1 and H, this is the gain after the negative feedback element eliminated. Here just I am going to write same as here, just observe these two, G3 divided by G1, and here G2, these two are enter into the single summing point, these two are in the parallel form. Okay, here this is the output C. Next, these are the in the form of parallel. We have a one more rule is there. If the two blocks are in the parallel form, we are going to just combine the two blocks into the single block. Just using the rule is here, combining combining the parallel blocks. Parallel blocks are G3 divided by G1 and G2. Right. Just I am going to write this is as it is 1 plus G1 and H. 1 plus G1 and H. And here G3 and G1. G3 divided by G1 and G2. These two are in the parallel. So these two are just parallel, means same signal enter the same. This the direction is direction is same into the combining into the single summing point. So just now we are going to adding these two block values or block gains. Here G3 divided by G1 plus in this block is G2 is there. Okay, G2, G1. Okay, this is C. Okay, now again just observe these two are in the form of again cascade form or else in series form. We have a one more rule is available. By eliminating the series blocks, we are going to redraw the into the single block. Right, now I am going to use the next rule is just eliminate the series blocks or combine the series blocks or cascaded blocks into the single blocks. Here just observe G3 divided by G1 plus G2. Here value is what? G3 plus G1, G2 divided by G1. Now I am going to write that one here, or G1 divided by 1 plus G1 and H. Next here just observe this value G3 divided by G1 plus G2. Just expand that one. G3 plus G2 divided by G1 and here also G1. After that, this is the output is same. Here now I am going to use the next rule. Here what is the step 4? Next step 5. I am going to use one more rule, combining the just observe these two are in the which form? Series form, right? Or else in cascaded form. So we are going to eliminate or we are going to combining into the series blocks into the single block, right? Combining the series blocks are cascaded blocks. Here single block is input is or and G1 divided by 1 plus G1 into H into G3 plus G2 into G1 divided by G1. Okay, this is into the single block representation. Okay, now here this is the output is C. Here the input signal is R. Just here observe G1 and G1 both are get cancelled. What is the transfer function here? We need to calculate the C by R ratio. That is the transfer function here. Transfer function C by R. Transfer function is C divided by R, means output divided by input, that is C divided by R is equals to G1 divided by 1 plus G1 into H into G3 plus G2 G1 by G1. Here G1 both are get cancelled. Finally G1 G2 plus G3 divided by 1 plus G1 H. This is the C by R. This is the transfer function. Finally this is the transfer function. Just here observe what are the rules are is applied here. Once again see here, just we have this is the block diagram, the given block diagram. Input signal and gain is here G1 and G2 and G3 is entered into the same summing point, the output is C here. I am going to consider here. This is our problem. Just observe in this. Here this is in the form of feedback, but in between block and summing point we have a one take point is there. There is no, there is a not there is a, we are not going to apply the any rule, because of between the summing point and G1 we have a one take point is there. So we are not going to eliminate directly here. So that's why we are going to use the take a point moving into after the block G1. After the block G1. Just here. After the block G1, just to move. After the block G1. So that's why we are going to write here G1 value is divided by G3 divided by G1 value. What we are having in this feedback or else in feed forward path, in that value divided by in block value means G3 divided by G1 simply. Okay, that is here. Just observe, these two are in the series. Again combine these two, G3 divided by G1, that is completed. And next here observe, this one is in the form of negative feedback and this is in the form of parallel. Okay, so that's why combining the cascaded blocks and also eliminate the negative feedback. Eliminate the negative feedback and combining the sales blocks, we got the value G3 divided by G1, and this is by applying the elimination of or eliminate the negative feedback. This is the feedback loop. After the elimination, G1 divided by 1 plus G1 and H, like that we got this, and these two are in the form of parallel. So that's why just adding these two block gains, simply we get the final transfer function, that is C by R equals to G1 G2 plus G3 divided by 1 plus G1 H. This is the transfer function of the given block diagram by using the block diagram reduction rules. These are the very important rules when we are going to reduce the any block diagram into the single block. That single block is nothing but the transfer function of the given block diagram. So that's why we are going to apply more number of rules. Which rules are going to be suitable for the given block diagram? That rules are we are going to use here, and we get finally the transfer function. This is the our main aim to reduce the block diagram to calculate into single block. That single block value is nothing but the transfer function. So these are this is the example problem for the block diagram reduction by using the block diagram reduction rules. This one is the very important for you. Okay, just for the today session we learn the basic rules are going to be applied for the given block diagram into the converted into or else reduced it into the single block diagram. The single block diagram is called as the transfer function. That is, the transfer function is output to the input. We learn from the today session, right? Coming to the next session, we are going to do the more number of problems. Thank you all.